Okay, so as I was saying, this chapter, we're getting into some logic. We're going to introduce you at the very end to proofs. Not a lot of numbers, other than the arithmetic series that we're going to talk about. So a little different than math classes you've been in before. This section talks about induction versus deduction. Induction is where you have to kind of make hypotheses based on information you're given. You aren't really given facts. You're given maybe patterns, and you have to try and draw some logical conclusions from patterns. And so induction is used a lot in science because you're following an experiment, you're getting data, and you're having to make some hypotheses. In math, we call those conjectures, but it's kind of the same thing. You're trying to say, well, based on this data, this is what I think is true. Okay? And there are things called counterexamples, which will prove your conjecture false. So as an example, if I use this information, I might make a conjecture that the square root of x squared is x. Does that seem logical? If x is 3, 3 squared is 9, the square root of 9 is 3. The square root of x squared is x. So I might say my conjecture is the square root of x squared is x. Can you think of a counterexample that would make this false? There is one. So can you think of it? There's lots of them, actually. Not necessarily, because I can make, like, even if it's a decimal, 1.03 squared, the square root of 1.03 squared is 1.03. Good job. Yep. What if x was negative 3? Well, what's negative 3 squared? Positive 9, right? Because a negative times a negative is the square root of 9, negative 3. No, it's positive 3. So Bo just found a counterexample to my conjecture. I made a conjecture based on a pattern, and then I found, as a class, with Bo's help, we found a counterexample that disproved my conjecture. So when it asks a question like, what is a counterexample for this conjecture, you're trying to find something that shows the conjecture is false. That's what counterexample means. Okay? The other piece in this lesson had to do with arithmetic series. What's the pattern here? Well, they're all odds. Could you make a prediction on what the next number is? 11. Okay. What about the next number? 13. So we're increasing the first number by 2, right? And we're adding 2 every time. And so on. Okay. What if it was, that was bad. And so on. What's happening here? Multiplying by 2 as I go, right? So this is multiplying by 2, and so on. So I could predict the next number to be 64. This is a arithmetic series. This is a geometric series. We're only going to be dealing in this section with arithmetic series. You're not going to be dealing with geometric. Okay, so we're going to be looking for trying to find a pattern with a sum. Okay, these are pretty easy when you first look at it. If you had a question on a standardized test and said, predict the next number, I'm pretty confident all of you would choose 11. What if I asked you to predict the 1,000th number. That's a little more difficult, right? Because I don't want you on a standardized test when you're timed to sit there and go 1 plus, and just keep going 1,000 times until you get to the number. So there's a faster way, and that's the equation that you learned in this section if you watch the video, which is pretty cool to have a shortcut. Okay? And if we go to the textbook check, I actually give it to you. A sub n equals a sub 1, and I'm going to go through what all this means, plus n minus 1 times d. Okay, a sub n, this just stands for something called the nth term. The nth term. So if I started with what I did before, a lot of times you'll see these series with 3 dots that just tells you it goes on like this forever. If I wanted the 1,000th term, a sub n is 1,000. Stands for the nth term, the term that I'm wanting. With me? Okay. A sub 1 is the first term. In this case, 1. N, well, I wanted a sub 1,000, right? So n is 1,000. D is the difference that you see between every term. What did we decide the difference was? Plus 2. If it started at 11 and went down by 2, it would be minus 2. Okay, so I can easily use this equation and tell you what the 1,000th term in this series is. The 1,000th term, I'll make it a sub 1,000 just to try and keep it. Come on. The 1,000th term is the first term plus 1,000 minus 1 times the difference. So that's 1 plus, what, 999 times 2. What's 999 times 2? 1998. That's the 1,000th term. 1,999. Okay, this works also when you see, sometimes you'll see shapes. 5. It's a 5. And then dot, dot, dot. What's happening here with shapes? It's increasing by one side, right? What if I said, well, this one might be pretty easy, but what is how many sides will be in the 536th iteration of this? Well, if this is 3, this is 4, this is 5, right? A sub 1 is 3. D is what? The difference? 1. And that's all I need. So I'm going to say A sub 536 equals 3 plus 536 minus 1 times 1. And that'll tell you the shape I'm looking for is going to have that many sides for the 536th place. Making sense? Okay. So it's kind of nice to have a formula for it rather than you sitting there on your paper and making shapes until you figure out which one it was. Right? Okay, this is called arithmetic series. Trying to find the nth term. So you'll have a couple problems on CK12 on this. You'll have a couple problems on your classroom problems. I do want to note the classroom problems, when I made them, I'm still trying to figure out how to use big ideas. But I don't like 2 of the questions I put in there, and I can't figure out how to take them out. So I think there's like 20 questions. I don't want you to do 18 or 19. If there's not 20 questions, I don't want you to do the next to the last one and the one before that. I think there's 20 though. So do number 20, but don't do the 2 right before it. And then your grade is going to show 2 less, but I'll know, and you'll still get 100 if you do the rest of them. Okay, so let's look at the textbook check real quick, now that I've gone through all of that. A conjecture is an educated guess. A counterexample disproves a conjecture. In the video, a system was described to find the nth term. If in the following problem, what is n? If I want to find the 35th term. What is n? 35. In the problem, what is d? The difference. 2. And in the problem, find it. So we would use a sub 1 is 1 plus 34 times 2, which is 68 plus 1, 69 would have been the answer. Just plugging into the formula. Okay. So that's it for this section. You've got CK12 and the big ideas problems for this.